these are the solutions to the multiple choice in your elephant packet. Those are the blue papers. I have put a quiz in Canvas for you to check these answers, and because of that, I'm not really going to go too in depth on these problems. If you have questions or you need a little bit more guidance on these, please just make sure that you ask me during class time. I'm just going to show you any work that I have on these problems, so I'm basically just going to flip through the page. Like, if you need help knowing how to solve these equations step for step, that's something that you should ask me, and it'll be really quick for me to show you in class or on a Friday. So this is page 31. This is 32. $33. $34. $35. $36. So I actually made the residual plot for number 12, 1.12. I took these points and split them between the x and y, entered them into my calculator, and then basically did all the steps here and found that when x is 10, that's the point that's farthest away in the residual plot. $37. So on number 13, this one was a little bit harder for me. If you look close, you can see that I was deciding between A and B. So we have to keep in mind on this set of data that the median or the middle of the data set is going to be where 50% is above the line or the median and 50% is below. So I went in and found out which bin 50% was actually in. So how I calculated that was I took 5 and I divided it by the total number of observations, and that was 140. So you can see here that I added them and got 140. That's 3.6%. Then to find 21%, I added 5 and 24 and divided that by 140. So that means 21% of my data is in that bin or below. Then to find this third number, I did 5 plus 24 plus 45 and found out that that is 53% of the data. So your median has to be at least 20 but less than 30, which splits you between A and B. Then I had a hard time deciding, well, is the mean going to be less than the median or is the mean going to be greater than the median? So I quickly graphed this. So these are the same bins as right here. So 0 to 10, 10 to 20, so on. And then I just graphed it. So like less than 10 has 5 observations. 10 to 20 has 24. 20 to 30 has 45. And I just looked at the shape of the distribution. It is slightly skewed right. So that means that the answer would have to be B. The answer would have to be B. I'm sure that's not the only way to reason through that problem, but that's the way I did it. (38) AP 2.1 tries to trick you, so they want to know, they ask you what's the maximum possible length of the right side whisker, which to me I read is what is the upper bound. So I used the information that they gave me and found the upper bound, which is 73, but then it wasn't here. So then I went back and reread it and was like, oh, they want the length of the whisker. So that means they want the length between quartile 3 and the maximum value. Because now we know that 75 is out here and it's an outlier. So we don't consider him, we just find the length between those two numbers. 2.3 is a sampling distribution question. These are 6 and 7. This is a continuation of the work for number 7. And then number 8 is kind of tough. I'm going to do my best to explain this to you guys, but I've tried to explain it to 2 of you, and I'm pretty sure that I couldn't do it in a way that made sense. So hopefully this makes sense, but if it doesn't, I'm honestly not sure how to explain it differently. So when we're talking about experimental design, random assignment's the best. Then completely randomized design. I said that wrong. The most basic one is random assignment. And then the next one would be completely randomized. And then the next one would be blocked, and then matched pairs. So if we're talking about which one of these is the best, well, let's go through them. First of all, this is not even an option because it only applies to sampling, and this is an experiment. So the best is a matched pairs design, then a blocked design, then completely randomized, then an SRS. So the best, I don't know how to describe this, but if we order these from best to worst, it would be, the best one is matched pair, block, completely randomized design, SRS. So this is the worst, this is the best. So I went through and did this problem and automatically chose matched pairs because I know matched pairs is the best experimental design that you can use. But then I checked my answer and it wasn't C. So then I was like, okay, well, it has to be A. The question is, though, why can we not do a matched pair for this particular problem? So one thing that I want you to keep in mind is that when you do a matched pair, you are pairing people that are similar. So you are pairing the 2 lowest GPAs, the 2 highest cholesterols, or one person against themselves. And in that case, the pair, you and you, is exactly the same. So you want your pair to be similar. You want them to be similar based off of the block. So what you are doing in this particular problem is splitting your participants into two groups. You're going to split them into employed, unemployed, and then you are going to assign half of them to, or actually, there's three different versions. A, B, C. A, B, C. Well, this picture describes why we can't use a matched pair design. Because, one, really what we want to pair is two employed people that are similar. But even if we match paired and did one employed, one unemployed, you have three treatments. So the issue is that a matched pair, you can't do a matched pair of one employed and one unemployed if you have three treatments, because you only have two people in the pair. And within each pair, you need to randomly assign. So here, this reasoning that I have, I don't think matters. It says within each matched pair, the subjects should be similar based on the block. The block is employment, so our matched pair would have to be employed and unemployed. Those are different, so we shouldn't pair them. Like, you should be pairing two employed, two unemployed. But regardless, in this case, there's three different advertising versions, or three different versions of the commercial. So you can't pair them. You can't use two people and three treatments. So that's bad. And you don't want to use the same person and have them watch all three commercials. That just wouldn't make sense. So now that I've drawn out the picture, it makes more sense to me why I can't use a matched pair. Because your block is employed and unemployed, and within each block you assign the treatments, and there are three treatments. For a matched pair, in our notes, we were introduced to matched pair. It's a common randomized block for comparing two treatments. The only case in which we were able to do more than two was the diet problem. But that was because we used each person as their own block. So each person can do all three treatments, but two people cannot do three treatments. Hopefully that's helpful. I apologize if it's not. This is better reasoning than this, so don't pay attention to that. Okay, page 40. '41. '42. On this bottom one, they're asking, according to the graph, the shortest 80% will take how long? Well, this is called a relative frequency graph. So this is 80% of the data. If you match that up to the line and go down, that's 10 minutes. So this means that 20% of the calls lasted about 6 minutes. I know that that line isn't straight, but it's pretty close. So the shortest 80%, I find 80% on my percentage, go over to the graph, go down, less than 10 minutes. You will definitely see one of these, so if you need additional support on that, please let me know. These are the z-criticals that go with those confidence levels. If you have sample sizes that are different, so here one sample is 400 and here one is 2700, you always want to change your y-axis to percent. You can't get an accurate comparison unless you change it to percent. You can't compare a histogram with 400 kids to a histogram with 2700 kids unless you change each bin to the percent of the sample that's in that bin. This one, we've seen several problems like this at this point. This formula here comes from the formula sheet. So refer to that if you need it. This is 46. $47. They give you the value of R for number 19, and you need to use R to find R squared. This one I think I struggled with, so I'm going to pause for just a second to see if I can figure out what I did. Okay, I remember now. So down here I found the position of the median and found that the median is, wait a minute. Isn't finding median, you do 1, 4, 3 plus 1 divided by 2, and that gives you 72. So your position of your median is the 72nd observation? Yes. So this is wrong. To find the position of your median, you do 1, 4, 3, your sample size plus 1, divided by 2. This means that your median is the 72nd observation. So I estimated the frequency in each bin and found the bin that the 72nd observation is in. That is 140 to 180. And then I was noticing that this distribution is right skewed, so I chose the mean that was bigger. Because we know that if a distribution is right skewed, your mean is going to be bigger than your median. And I didn't know how to decide between the two, so I chose the one that was bigger when really it was A. And then I started thinking about it, and your mean is not going to be a lot greater than your median unless you have outliers out here. So I shouldn't have chosen the interval, the highest interval away from the median, because we don't have any outliers that are really pulling the mean out. We just have right skew. So A is the better option there. So that was my understanding after I checked solutions, was that unless you have outliers, your mean will be greater than your median, but it's not going to be like really far away unless you have outliers. Okay, 49. $50. On number 25, which of the following has the highest power? We mentioned this in our notes, but this is a really good example of it. The highest power is given, or the observation that has the highest power is the one that's farthest away from the claimed value. So remember our basketball shooter, a guy that can hit 60 when he claims that he can hit 70%, not that bad. But let's say he only makes 20% of his shots, then we're pretty sure that he's not telling the truth. So the more obvious the difference, the greater the power. So this is 2 away, but so's this one. Then I went to my alternative and realized, okay, they're testing if it's less than 40, so I need to choose the one that's less than 40. So it's the one that's farthest away that's less than 40. It's 51. $52. This one's really important, so I would make sure that you totally and completely understand this problem. And then that is it for the multiple choice solutions. I hope that if you needed help, that helped you, but like I said before, on the multiple choice, if you need more clarification, you're going to need to ask me in class or come and see me on Friday so that we can talk about it, which I'm happy to do. The free response, I try to go a little bit more in depth, but on the multiple choice, because the answers already give you a little bit of support, I explain less. So if you need more explanation, just come see me. Okay, that's it. Love you guys.